Hi guys, this is Bruce. I teach math, AP Calculus, Pre-Calculus, Statistics, and sometimes physics, especially AP C Mechanics, and A-level Mathematics and Physical Mathematics. Why I'm doing this video? Well, it is because that I'm in a sick, so I the doctor said to me that I should lay down and have some rest, but it is too boring. So I just did this. And okay, maybe there are some other reasons. For example, in my classes, my students often need to practice those past papers, and I usually spend a lot of time going through these questions with them one by one. So I thought, why not record the explanation in advance and put them online so that those boys or girls can just watch them anytime. And I can save a lot of time for both of us. Okay, to be honest, another reason is that I want to promote my personal teaching. Yeah, it's kind of embarrassing to speak about it. But like I said, I teach math and physics. So if you have questions or if you are struggle with courses that I mentioned above, why not try to approach me and get some help? I think personally, my class is helpful and affordable. So that's it. Okay, let's start talking about something about the questions. These questions. We know the AP exam. It happens in a lot of regions, and these specific set of questions are for Asia Pacific region. So this is the question for Asia Pacific region. But I know maybe a lot of the audience here might want the version for North America, or I don't know. The question is that I don't have that paper. So if you have, and if you are willing to share it, you can send it to me via email, I guess. I don't know. And I can make a similar video, just like this one. Okay. Okay. Maybe some of you want to try this paper first, and then go back to listen to the explanations. So I will, in the comment, or description, I will give you the places that you can download this file. Yep. Okay, and there's something I shall mention. That is, the original material for these questions is like this one. I get it from the internet, and forget about those red circled ones. This is the answer that provided by this original document to the end of it, and some of them are wrong. I just circle them because when I finish this, I need to check the answer. So don't believe those answers. And the most important thing is that, okay, maybe this is a perfect example. So let's see these questions. This question says, okay, let F be a differentiable function that is blah blah blah. And what is important is here, which of the following could be the graph of f prime? And okay, you just go to the choices and boom, there's no graph at all. Yeah, there is no graph of in this document at all. I mean, every graph it described it use words instead. So which is a pretty awkward thing. So how to solve this? I just okay, let me show you. I just draw this picture on my own based on these descriptions. And here is the thing. I am not a student. I'm a teacher. What I want to say is that I don't go to take the exam this year, so maybe my figures are not the same as the official ones. But I think, personally, the difference is not big, or that it doesn't matter, because it won't affect the interpretation I'm sorry, of these questions. But if you know the official ones, and the difference is big enough to that to the extent that will affect the interpretation of the question, you can let me know, or just feel free to point out in the comment, or just send me a message, and I will try to correct them. Okay. Yep. Oh, let's go to these files again. Before we start, there are a lot of several things. One thing, yeah, this part is the multiple choice questions, and in the original files, it carries choices, but I don't write them. Why? Because lazy. Okay. Honestly speaking, I am in a EO, just like I said. So, the total number of the line is approximately, I guess, 700, and please allow me to just don't attach those choices. You can do it like free response questions, right, my friends? Okay, that's the thing. Just forgive me. I just you can't be too tough for EO man, right? So let's get to the questions. Okay. Yeah. Oh, I'm sorry. Like I said, I really have a cold. So maybe I cough or sneezing. I will try my best to prevent this, but it's a natural thing. I hope it won't bother you so much. Oh, one more thing. This is a BC version of it, and why it is not AB? Because come on, guys, just to reach out for BC, right? Because during the explanation, I will show you. It's not a big thing. It is solvable if you are diligent. I mean, if you just follow the instruction of your instructors or or my instruction, if you're interested learning with me, it's a small cake. Okay. And oh, my plan is to give explanations for calculus, mechanics, and statistics. And why I chose calculus to be the starting point, it's just a completely personal preference. Okay. Just a simple answer. Just a personal preference. So let's head to the problems. Okay. Okay. This is an edited video. What I mean is that I recorded several video and I edit them, put them together. And just now I turned up the volume of my microphone because I think in the first clip the volume is rather small, so I turned up it. But I find that there are some background noise, and it turns out that those noise comes from my AC, and it's summer. I I'm sorry for this. I am poor. POOR. Okay, so I just rent an old apartment, and the AC here is pretty old, so there are a lot of noise. I will try to solve it maybe in the next video, but this time please forgive me about this. I'm sorry. Oh, another thing is that I have to admit that I'm not a native speaker, so my grammar and vocabulary sometimes may not so accurate. I think it won't bother you in the understanding of those explanations, but I apologize if you feel difficult. Okay, let's start with question 1. So question 1 is just ask us to find the derivative of this function, and all you need to know is actually first the so-called power rule. That is, okay, suppose we have a function which is x to the power of alpha. Here alpha is a constant number, which means it can be 1, 2, 3, things like this, and its derivative shall be alpha times x to the power of alpha minus 1. The next thing you need to know is chain rule. This is it. And okay, so we shall say the whole thing in the bracket as a whole, and we take its derivative, and it's just like a power function. So okay, 1 over 4 times the whole thing, and here it's 1 over 4 minus 1, which is negative 3 over 4, and times, don't forget, okay, chain rule, don't forget the derivative of the whole thing. That is, okay, actually 3, its derivative is 0, so it's just this part, which is 10x, so the whole thing is this. Okay, you can simplify this expression, but I remember in the original material the choices just looks like this one, so let's just write it in this way. For question 2, we know that we have a function f of x, and we know its derivative. I'm sorry. We know its derivative, which is this, and we know that when x equals 1, its function value is -3, and we are going to find f of 2. We can solve it by using the so-called fundamental theorem of calculus, the evaluation part. There are several names of it, actually. Some books also call it integral evaluation theorem, or some books call it Newton Navier formula. Anyway, just this formula. And here, big F of b is actually, we can think of it is f of 2, and here it is f of 1, and here a and b, it is 1 and 2, and the function inside, it's the derivative of f of x, which is f prime of x. And this integral, the result shall be this one. You can check it. For example, this one, we take its derivative, 2 times 3 times x squared, which is 6x to the power of 2. So that's it. And the next thing we need to do is just substitute x is 2 and get its value, and substitute x is 1 and get its value, and find the result, which is 16. But this is not the result we want. Don't forget, what we find is actually f of 2 minus f of 1 is equal to 60. Okay, so this is not f of 2. But we have known that f of 1 is -3. So from this, we can actually get what is f of 2. And the final results shall be 13. You can think of it in another way. That is, you can think of it as a problem for ordinary differential equation. Okay, this is just the dy dx, and this is the so-called initial condition, and you can solve it, find the original function, and just find its function value when x equals 2. Both ways is okay, but I think this is the this is the easiest one. Okay. For question 3, I'm sorry, we have a function which is x of sine of x divided by x, and here the problem is, what is the instantaneous rate of change of f at x equals pi over 2? Here I want to start with the idea of rate of change, or average rate of change. So what is average rate of change? If you have some background in physics, I think it's pretty straightforward. Let's say let the function f represent the distance you have traveled. So f of a here just means, or just represents the distance you have traveled at the time t equals a, and this one, of course, is the total distance you have traveled at the time a plus h. So the difference of those two things is actually the distance you traveled in the time interval h. Okay, this is actually the so-called change, right? Change. And what is rate of change, or average rate of change? It's just okay, the total distance divided by the time you have used. So this is average rate of change. And what is instantaneous rate of change? All you need to do is to make the length of the time interval, which is h, as small as possible. That is, you let it approaches 0. So we get this, and this actually is the definition of the derivative of f of x at the point x equals a. So instantaneous rate of change, it's just a derivative. So what we need to do for this question is, first we find the derivative of this function, and then we just substitute x as pi over 2. So first we need to find its derivative. And to find its derivative, it's a quotient, so we shall apply the quotient rule. So for the denominator, it is just the square of the original denominator. And for the numerator, okay, we shall first start with sine of x and its derivative, its cosine of x, and times the denominator, which is x, and minus the derivative of x, which is 1, and times the numerator, which is sine of x. And okay, now we just put or plug pi over 2 into this expression, and as you can see, there is a simplified version. And okay, cosine of pi over 2, guys, cosine of pi over 2 equals 0. So you can just ignore this part, or just write 0, because 0 times anything is 0. And this part, sine of pi over 2 is 1. So 0 minus 1, which is negative 1. And for the denominator, it's just the square of the input. So we just do some simplification. We get the final answer, which is negative 4 over pi squared. This is question 3. Question 4. I'm sorry. Question 4 give us a function or a table that the first row of it just shows the time, and the time in hours, 1.25, etc. The second line is a function represents speed. Now, actually, it just shows us a function in the way of a table. So, which means, okay, when t is equal to what, then s of t is equal to what? S of t equals to what? And okay, let's go to the problem part. That is, okay, it asks us to using a midpoint Riemann sum. Here is the important thing: Riemann sum and midpoint Riemann sum. Okay, with subintervals, this one, this one, this one, and then what is the approximate distance in miles the car traveled from this to this? Okay, Riemann sum. Its formula is like this one. Okay, maybe different books have different forms. I mean, those letters can be changed, but the idea is the same. I want to speak something about it. That is, if you ask someone, a mathematician or a math lover, or just your classmates who are interested in math, why they have a passion about math or things like physics, I think a lot of replies or answers will be compared to things like biology, history, or etc. You don't need to remember a lot of things in mathematics. So it seems that there is a paradox that if you don't know this formula, honestly speaking, you cannot solve this question. But on the other hand, it seems that every people loves mathematics. I told you there is little things to remember. So how can we solve this paradox? I think, personal opinion is that those formulas include this one, and even the so-called average rate of change. Those formulas in mathematics and physics, they have an idea behind them. And if you know the idea, you can remember it without pain. So, this looks terrible. But what about the idea behind it? So I just maybe use this textbook to illustrate it for you. So Riemann sum. Riemann sum is a thing that we introduced when we are studying definite integral. I'm sorry. And what we want to do in the first place, maybe we can use this diagram to show you. That is, okay, we can find we want to find the area which is enclosed by first the graph of the function, second the horizontal axis, third x equals 3. Those three things. But without definite integral, it seems that we cannot do it. Why? Because it's not a spatial. It's not a spatial geometry object like triangular. You know, for triangular we have area. We have formulas for its area. Or parallelogram, we have formulas. Square and etc. But for this one, we don't have a specific formula. So the idea is, okay, why not strip it to little strips like this, like here, and okay, we shall use the last strip here for illustration. If the term shall be partition. I mean, if you are going to use some professional vocabulary, it shall be partition. If your partition, the result of your partition results in small subintervals, then those things, we know it is not a special geometric object, but if the subinterval gets smaller and smaller, it is more and more likely or more and more similar to a rectangle. Or in other words, we can use a rectangle to approximate the area of it. That's a fundamental idea of no matter Riemann sum or definite integral. Then, speaking of rectangle, guys, what is the formula for a rectangle? It's just the length times the height, or the length times the width. Okay, then what is the width of this triangle, of this rectangle? It's just first the width the width of it. Actually, the width of it is, or the length of this side, is just the length of this interval, this subinterval. And what is the height here, or the length of this side? Okay, actually, there for the height, you have multiple choice. You can choose the left end point, you can choose the right end point, you can choose the midpoint, you can choose actually any point. But in our problem, it asks us to use the midpoint. Honestly speaking, we have a more similar graph. The idea is just this. We use this rectangle to approximate the area of this one. And that's the fundamental idea. So now, let's go back to the formula I just wrote. What's the meaning of this formula? It's just here it is just the length or the width of the rectangle. Here it is the height of that rectangle. So I think if you really know the fundamental idea of it, or the idea behind this formula, you can just remember it. Pretty simple. So for these three subintervals, for example, let's use this one for illustration. First, what's the length of the interval, or what's the horizontal length of that rectangle? That is the length of the interval, which is 1.5 minus 1, which is 0.5. And what is we're going to use midpoint. What is the midpoint of this subinterval? It's just 1 plus 1.5 over 2. This is how we calculate the midpoint of an interval. So you get 1.25. And so now the lenses of a rectangle. So we just need to multiply both of these. So again, for this interval, the interval's length, 3 minus 1.5, you get 1.5, and the midpoint is just 2.25. Okay, and here pretty similar. And then all you need to do is to use this table to find the function value at these midpoints. So this one 50, this one, as you can see, 70, and this one 60, and then just some simple calculation, and it turns out it's 190. Okay, let's go to question 5. Question 5, here we have a piecewise defined function, and for this one we'll have to read its choices, and all of these choices their words continuous and differentiable. So this is a question about continuity and differentiability. To solve this, I think we shall recall one theorem, that is this thing. Okay, suppose we want for a function f, we want that the limit of this function at the point x equals a exists. What do we need? We need two things. We need this thing, which is called the left-hand limit, and this thing, right-hand limit. Both exist. And exist means that this can be some value like 1, 2, 3. This can be some value 1, 2, 3. Those two things must be exist, and the value of them shall be equal. So if this is true, then we can say this one exists. This is the theorem that we are going to apply here. And now let's talk about differentiability first. Why? We will see why. So, speaking of a function's derivative at a specific point, say x equals a, its definition is this one. Actually, we have seen this in previous questions. Instantaneous rate of change, that problem. And as you can say, fundamentally speaking, derivative is just is defined as a limit. So if you want this limit, or let's say this in this way, if you want derivative exists, of course, what you really want is this limit exists. And if you want limit exists, according to the theorem, what you need to find is this left-hand limit exists, and this one exists, and both of them are equal. And this thing, it's called left-hand derivative, and we have a symbol of it. And this one, it's called right-hand derivative, also the symbol of it. Okay, so for piecewise defined function, our focus point usually is is a bound, bound of each branch. Say here x equal to 0, here x equal to 1. So why not start with x equals 0? Okay, we just apply this formula, and here f of x, and here f of a, and because we're talking about the point x equals 0, so it shall be f of 0, and the denominator, it is x minus a. Here a is 0, so it's x minus 0 actually, but minus 0, so you can just write x. And let's pay attention to this one first. I'm sorry. Okay, when x approaches 0 from the left side, which means x is smaller than 0. So let's go back to the functions. Let's go back to the function. Which branch shall we pay attention to? This branch, because this is the branch that when x is smaller than 0, so the expression here shall be 1, just like here. And what is f of 0? Okay, you can say 0 is included in this branch, so 0 squared, which is 0, plus 1, so the result is 0, so is 1. So f of 0 is equals 1, and for this, okay, we can say it is 1 minus 1 divided by x, and the numerator is completely 0, so the whole thing is 0. And for the other side, okay, all you need to modify is just the expression of f of x. And let's go back to the function again, and this time we shall use this expression because it is x approaches 0 from the right side, which means x is bigger than 0, so this expression, so we just write this to this. And here, as you can see, plus 1 minus 1, so x squared remained, and here is x squared divided by x, so it is x, and for this limit the result is 0. Okay, we have find this one exists, and it's 0. This one exists, and 0. So according to this and this, we can say that for function f of x, it is differentiable at the point x equals 0, and actually we know its derivative, which is 0 at this specific point. Another thing is that, okay, it's a pretty important and important but also simple thing, that differentiability implies continuity, right? So if a function is differentiable at a specific point, it must be continuous at that point too. So for this point, for x equals 0, this point, the function is both differentiable and continuous. Okay, let's talk about another point, which is x equals 1. The method is pretty similar, you can see. All we need to modify is, okay, here it is f of 0, here it shall be f of 1, and here it is x minus 0, here it shall be x minus 1. Of course, here it is as x approaches 0, it shall be, at here it shall be 1, and everything else is pretty similar. And okay, f of 1, we can go to find the value of it. You shall find it in this branch, 1 squared plus 1, which is 2, so f1 is equal to 2, as you can see, 2, so minus 2. And speaking of the expressions, pretty similar. For left hand, you shall apply this. For right hand, you shall apply this. So we get those limits, this one and this one, and do some calculation. Okay, for this one, we have this one. I mean, from here, we can write here this, and the numerator is x squared minus 1. It is a difference of square, right? It equals x minus 1 times x plus 1, and x minus 1 can be cancelled by the x1 in the denominator, so the final result is this one, and when x approaches 1, it is 2. And for this one, pretty similar, but the final result is 1. So when x equals 1, the left-hand derivative exists, and the value is 2. The right-hand derivative exists, but the value is 1, which means this one does not exist. Okay, we need these two numbers to be equal so that this one exists, but it is not true at here, so this thing do not exist, which means f of x is not differentiable at this point. Okay, but guys, a function is not differentiable at a specific point cannot imply that this function is not continuous at that point. So we shall check the continuity. Okay, so what is the definition of continuity or continuous? It's this. The meaning of this equation is that, okay, when we say that a function is continuous at some specific point, say x equals a, what we mean is that first, f of a exists. Second, the limit at that point exists. Third, the two things are equal, and this is continuous. And okay, here again we made what? We made a limit, and if we want to check either it exists or not, we shall going to find or going to check the left hand or right hand limit. And okay, when x approaches 1 from left, again its expression, we shall use this branch, and when x approaches 1 from right side, we shall use this expression. So we have this one and this one, and when as you can calculate, those two things both equals 2, so this one exists and equals 2, this one the same, which means this one exists and equals 2, and we have already known that f of 1 is 2, so this one equals this one, which means f of x is continuous at this point. So let's go back to these traces. As we can say, B is the right one because it said f is continuous for all x, yes, and differentiable except it equals x equals 1. Yeah, that's the thing we just found. But we can also take a look at those remaining choices. Okay, for A, x equal 1, right? For C, it says, okay, f is continuous for all x. This is right. And differentiable except at x equals 0 and x equals 1. This is right, right? This is right. This is our findings or discovery. But this fx is differentiable at this point, right? We have just to check this. So we cannot choose C. And for D, f is continuous except at this point. Actually, we have just find f is, it is continuous. So we cannot choose D. So the right answer, again, shall be B. Question 6. Question 6 said there is a function which is differentiable and it is decreasing on the interval from -1 to 1 and increasing on these two intervals. And it asked which of the following could be the graph of f prime, the derivative of f. B and D can be easily excluded. Why? Because depends on the question, depends on the description, the function f is decreasing on the interval from -1 to 1. But you can look at this part and this part. I mean, these two parts. From -1 to 0, both this one and this one, its sign is positive, which means if it is the derivative of f, then the function should be increasing. But it is decreasing actually. So contradiction. So B and D excluded. Now A and C. If you check the sign of A and C, you will find both one are okay. For example, as you can see, from -1 to 1, it is negative and decreasing. Yes, and for this one, negative, so decreasing. And so I mean, from sign, you cannot pick up a answer. So we need another thing to get rid of one of them. And the theorem we are going to apply is actually this one, intermediate value theorem for derivatives. In some books, it is also called, to be honest, I don't know how to pronounce this word. It's a mathematician's name. Okay, so let's head towards to the content of it. It says, okay, if A, B are 2 points in an interval which f is differentiable, then f prime takes every value between f prime A and f prime B. Okay, let's just use this theorem to think of option C. Suppose this point, which I labeled to be point A, and as we can say, the value of it shall be 1, which means which means that f prime A, if this function is the derivative of f, shall be 1. And let's see this point, another point which I labeled. Okay, suppose it is B, then we can say that f prime B is equal to f prime of B is 2, is -2. So we say here f prime A shall be 1, f prime B shall be -2. So if it is a derivative, then the function can take every value between -2 to 1. But hey, let's say I just draw a line here, pass through the point -0.3, and as you can see, no points of the graph, just there is no intersection between the graph and this horizontal line, which means it cannot take the value -0.3, which is actually between -2 to 1. So it does not comply with this theorem, which means this cannot be a graph of a derivative. So the answer shall be A. Okay. For question 7, let's say. Question 7 is a question about parametric curve, and here x is a function of t, and y also a function of t, and it asks, okay, what value of t does the curve have a vertical tangent? You're going to find tangent, so tangent, which means you are going to find derivative. And for parametric curve, to find its derivative, we're going to use this parametric differentiation formula. dy dx, which is the derivative, it equals, okay, the derivative of y with respect to t divided by the derivative of x with respect to t. Of course, the denominator cannot be 0. And apply this to this question, so we can find that, okay, for this we get t squared, take its derivative, it's 2t, and this give us -6. For this one, x of t, we just take its derivative, and we have 2t minus 4, and simplify it, we get t minus 3 divided by t minus 2, and it's pretty clear that when t approaches 2, this is, the whole thing is approaching infinity, and this is where we have a vertical tangent. Oh, I read something wrong. There shall be t equals to not x. So let me correct this. And of course this. And everything else is right. And I think this is a simple one, right? Okay, for question 8, we have a function, and this function has a second derivative, and we're also given the expression of its second derivative, which is this one, and the question is, how many points of inflections does the graph of f have? Here, guys, points of inflection, I want to first ask you a question, that is, what is the definition of points of inflection? Is it the point that the second derivative at that point is equal to, the second derivative at that point equals 0? No, that's not. Actually, the definition of points of inflection is that the shape of the function changes at that point. What I mean is that, okay, suppose shape here means concave up and concave down. What I mean is that, okay, suppose we have a point of inflection, then previously the function can be concave up, but then it just it just turns to be concave down, or vice versa, concave down turns to concave up. That's a definition of point of inflection, not this one. Don't forget this. Okay. To solve this question, we can use a simple sign diagram, and to analyze the sign of this expression. Okay. So let's start talking about this part, which is when x is smaller than 1. When x is smaller than 1, the expression, the first factor of the expression, x minus 1 squared, shall be positive. Actually, it is always positive, because we are not going to talk about what happened when x equals 1. So, square, so non-negative and positive. For this part, x minus 2, because x is smaller than 1, then it is smaller than 2, so it's negative, and negative, and here pretty similar, negative. So positive times negative, which gives us positive, which means when x is smaller than 1, the sign of the second derivative shall be positive. Okay, then let's investigate this part, that is when x is bigger than 1, smaller than 2. You will find that this part, the three factors, their signs does not change, do not change at all. So the sign of the second derivative in this interval is also positive, and from positive to positive. There's no change of signs, which means the shape of the function does not change. So x equals 1 is not a point of inflection. And let's continue. For this interval, that is when x is bigger than 2, smaller than 3, this remains to be positive, but this, okay, now x is bigger than 2, so it is positive, but still smaller than 3, so it is negative. Positive, negative gives us negative. So the sign of second derivative shall be negative, and as you can see, from positive to negative. So the sign does change. So the shape of the function changes too, which means x equals 2 is a point of inflection. And now let's look at the last part, that is when x is bigger than 3, and all these three factors are positive. So the sign shall be positive, and again, from negative to positive. From, if you think of shape of the function, from concave down to concave up, so x equals 3, also a point of inflection. So there are 2 points of inflection, x equals 2 and x equals 3, but x equals 1, it is not a point of inflection. So the final answer shall be 2. I mean, how many? There are 2 points of inflection. Sorry. Okay, question 9. We have a position vector, this one, and it asks what is the acceleration vector of the particle at time t equals 1/2. Okay, so to begin with, we have the position vector, and take its derivative, we can get the velocity vector. This is a vector. If you are not familiar with taking derivative of a vector, it's actually just take the derivative of this part, so you get this, take derivative of this part, so you get this part. Pay attention to this. It is sine of pi t, not sine t, which means you shall apply chain rule. So sine of something, so its derivative shall be cosine of something, and inside of it, it's pi times t, so its derivative is pi. So we have pi here, pretty similar here. So we get the velocity vector, but not enough, because we need acceleration vector. So we just take derivative again to get the acceleration vector, pretty similar. And again, pay attention to chain rule here, because you need to apply it again. So we finally get this. And it asks us what's the value of it when t equals 1/2. So you just substitute t as 1/2 into this expression, and when t is 1/2 sine pi over 2, it is 1. So 1 times negative pi squared, it is negative pi squared. For this one, cosine pi over 2 is 0. So you get 0, and this is the final answer. Question 10. Question 10 says, what are all values of p for which the series, okay, this one, converges? For this one, you need to know a thing or a category of thing called P series. It is infinite series look like this one, that is sigma n equals 1 to infinity, and here n to the power of p, and the numerator shall be 1. Here is an interesting thing, that when p equals 1, we get this, right? That is when p equals 1. If we write it out, it shall be 1 plus, 1 over 2 plus 1 over 3 plus blah 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 blah. This series has a name, if you are interested. It's called harmonic series. It's actually pretty important, a series. Why? Because a pretty important characteristic or feature of P series is that, when P is bigger than 1, this infinite series will converge. But when P is smaller or equal to 1, it will diverge. So harmonic series is a boundary between diverge and converge. Okay, back to this problem. If we want these converges, well, all we need to do is to make sure the index here, which is 4p minus 1, is bigger than 1, so that the series will converge. And we just solve this inequality, lead us to p is bigger than 1/2, and that is the answer of question 10. Question 11. Question 11 says, if 10 people have heard the news at time equals t, how many people have heard the news when the rate at which the news is spreading changes from increasing to decreasing? That is a problem, and the remaining things are some definitions. The first is that we have a function p which models the number of people at a business who have heard a piece of news at time t. That's the first thing. The second thing is that we have a logistic differential equation, this one, which models the rate at which the news is spreading. So guys, here we actually have two things. One is a function p, it is a function of t, and we have its derivative. So this question, I want to ask you guys, ask either this one changes from increasing to decreasing, or this one. So you shall pay attention to the question itself. It asks the rate at which the news is spreading, which means it asks this one, not this one. You should pay attention to this, because if you get it wrong, if you think it is asking about this function, then you might think, okay, this function from increasing to decreasing, okay, we just need its derivative changes from positive to negative, and boom, you get the answer 4,800, which is wrong. So just when you are reading the question yourself, please be more careful. Back to the differential equation again. Actually, this question has already told you that this is a logistic differential equation. Logistic differential equation. Some books might write it in this way: dp dt equals k times p times m minus p. The first thing I think some students might wondering this: there is m minus p, separate p, no coefficients, or you can think of the coefficient can be 1, but here it is not a separate p. So why it is a logistic differential equation? how to say this, guys? I'm not a native English speaker, so when I was young and when I was learning English, I have to remember vocabulary, and my learning method for remembering vocabulary is pretty clumsy. For example, for this word spreading, it is okay. I will read it spreading, and I will read its spelling, which is which like this, spreading, spreading. But this is not the way to learn mathematics. What I want to say is that for those equations, its pattern, yeah, matters. But what really matters is the idea behind it, and the idea behind it will lead you to remember those formulas, and not only this formula, but remember the essence of it. So how to remember it, essence, how to remember it, or how to understand this is, okay, why not look at here. So initially, actually, we start at this differential equation, dp dt equals kp. Here, k is a constant, is a positive constant. You can solve it, actually, by using the method separation of variable, and the result will be an exponential function. And we can use this to do what? To model, for example, the growth of population. And let's be more specific. Suppose we have an empty city. I speak as New York, say. And we just put some peoples at this empty city. Initially, the growth rate of population might be exponential. Might be exponential because there are a lot of factors might affect the population's growth, such as disease, such as weather, etc. But it might be exponential. But guys, think about this. Even city, I speak as New York, has its limitation. What I mean is that when the population has already reaches a pretty high level, the growth rate of population must slow down. So the idea of logistic model is try to model this on the foundation of exponential growth. So how we actually do this is by multiply further or additional factor m minus p. By multiply this, you can say, okay, when p gets larger and larger, this factor will get smaller and smaller. Yes, this might keep rising, but this slows down. So the final result might be in a balanced, or it just can cancel some effect of the previous factor. And what's more important is, okay, m here, we call it, actually it has a name, we call it carrying capacity. It's like this. Okay, we can see that when p equals m, the whole thing equals 0. Why? Let's go back to our example of put some people into the New York City. If the population of New York City has already reached the limitation of the city, what I mean is that there are some limitations. For example, the places people can live, and the food it can provide, and the water it can provide. If the population has already reached the maximum capacity of this city, then the growth rate will be what? Will be zero, because there's no room for more people. So that's the fundamental idea of logistic model. So back to our problem. These differential equations, we can say, okay, it is not m minus p, but first, this is also linear, right? Just like m minus p. Second, as you can say, when p gets larger and larger, this thing gets smaller and smaller. And more important, or furthermore, when p is 4,800, this thing will be zero. So you can, if you really knows about logistic model, knows about the notion, the idea of it, you can just tell what is m here and why it is a logistic differential equation. Of course, we can rewrite this expression to match this standard form. How can we do this? We can just factor 1 over 4,800, and furthermore, we can get this, which is the same as this one. And okay, the next thing is a conclusion about logistic model. That is, when p equals 1/2 of the carrying capacity, the growth rate, which is dp dt, reaches the highest level. Okay, so for this one, because the capacity is 4,800, so when p equals 2,400, this will be at its highest level, which is the point changes from increasing to decreasing. If you are interested why this conclusion is valid, actually I can tell you. That is, okay, let's go back to the differential equation again. Guys, this one, if we think of it as a function of p, I'm sorry, a function of p, then what kind of function this is? This is just a constant number. We can ignore this. This thing, it is a quadratic function, right? And furthermore, it is a open down quadratic equation, concave down. And for quadratic equation, we have a so-called vertex, and because it is a open down quadratic equation function, the vertex is the maximum point. Okay, then how can we know this vertex? You have to recall one more thing, that for quadratic function, the graph of it is symmetric, and how to find the axis, or how to find the line the graph is symmetric about. That is, okay, it's pretty simple to identify that when p is 0, the whole thing is 0, and when p is 4,800, this is 0. I mean, the whole thing is 0. So 0 and 4,800 are two zeros of this function, and to find its line of to find the line the vertex it lies on, you just can write, okay, 0 plus 4,800 over 2, which is this one. Okay. What if you just forget logistic model? You forget this, the whole idea of it. Can we do this? It turns out we can, just by calculating the second derivative of p with respect to t. I show this process here, and then you can just check the signs of this, and as you can see, the point when p equals 2400 is a point that the sign changes from positive to negative. So you can also get this answer, but to be honest, this calculation, it is not so heavy, but compared to remembering the conclusion for logistic model, I think to remember the conclusion is more easy. So I hope you can remember this. Okay, question 12. Question 12, okay, pretty standard question about implicit differentiation. In implicit differentiation, according to my personal experience, a lot of students might forget the chain rule when they apply this kind of method. And how to avoid this, my personal suggestion is that, okay, you can write y as y of x, and then you can rewrite this function as this one. And now let's do the implicit differentiation. This one 2x, this one minus, of course, ahead, and this one is a multiplication. So we first take the derivative of x, which is 1, and 1 times y of x, okay? And then we take the derivative of this one, and this one is its derivative, pretty easy, y prime x, and don't forget 2 times x, and that's the derivative of this part. The final part, okay, first it shall be 3 times 2, which is 6, and times y of x. But don't forget, this is a function of x, so you need y prime of x. And the other side, don't write it as 6, okay? This is a constant number. Take the derivative of it, it shall be 0, and we get this. And we just collect the terms containing y prime, and we can get this, and some rearranging lead us to this, and we can just solve what is y prime. Okay, question 13. Question 13 asks, what is the radius of convergence of the series? Radius of convergence. Okay, to get it, we shall apply the ratio test. And the ratio test is just I'm sorry, the absolute value of the n plus 1's term divided by the absolute value of the nth term. And for this one, the n plus 1's term is this. Okay, 3 is 3. N becomes n plus 1, and x to the power of n becomes x to the power of n plus 1, and the denominator pretty similar. And divided by the nth term, divided something is the same as times the reciprocal of it, so we can write it in this way, so we get this. And here, okay, we can do some cancellation. For example, 3 and 3 can be cancelled, and here x to the power of n plus 1. Here we have x to the power of n, and cancelled. We just have x remains. And okay, if we arrange it, we get this. Okay, and here for this one, when n or as n approaches infinity, the whole thing approaches 1. The reason is that okay, we can just think of the highest order term of the numerator, which shall be n cubed, and also the highest order term of the denominator, which is also n cubed, and so it is 1. So the whole thing, if we evaluate it, is the absolute value of x, and we set it to be less than 1, and we get this. So the radians of convergence is 1. That's for this question. Okay, this question just asks the radians, but what if it wants you to find the interval of convergence? That is, you have to considering those endpoint. Okay, I also showed you of this. So when x equals -1, as you can see, it becomes -1 to the power of n, which makes this series to be an alternating series. And for alternating series, we have our method, right? We shall check that the nth term is bigger than the next term, and of course we shall also check that the whole thing, the nth term, its limitation when n approaches infinity is equal to 0. Both is okay. So when x equals -1, it converges. What about the other endpoint, that is when x equals 1? So we get this. For this one, actually, we shall compare it with this one. Why? Because if we divide n on both numerator and the denominator, the things remains in the denominator will be n. So the end behavior of this one is pretty much like this one. So we use the method which we called limit comparison, as you can see here, and the result shall be 1. So according to limit comparison test, because this one, it diverges. Okay, it's just a p series times 3, but times 3 times a constant will not change, diverge or converge. So this one diverges, and so this one will diverge also. So if this question asks the interval of convergence instead, this point, -1 will be included, but this one will not be included. Okay. Question 14. Question 14, here we have a graph, and we have some regions. The first region we labeled as A, the second we labeled as B, and it says each region, the area of it is 3, and it asks us to find the value of this thing. Let's first talk about this one, this integral. Okay, from 0 to 4, this integral, what's the value of it? It is the area of A, not completed right. Why? Because this area is below the x-axis. So the real answer is the negative value of it, which is -3, because its area is 3, so -3. Then for the next part, it is from 0 to 7. From 0 to 7, we can separate these into two parts. The first part is from 0 to 4, which we have already solved, and the second part is from 4 to 7. From 4 to 7, according to the graph, is actually it is actually the area of B. So for this one, it equals, okay, the previous one, which is -3, we have already defined, and this one is 3, so it is 0. So the whole thing, the later one is 0, and the first one is -3, so -3 plus 0 equals -3, and that's it. Okay. Question 15. Question 15 is actually not hard. All you need to know is that the inverse function of sine of x, its derivative is this one, 1 over square root 1 minus x squared. So it is this one. But don't forget what, guys? Don't forget here we have a problem of the chain rule. Honestly speaking, for this one, if you forget about the chain rule, you will still get the right answer. Why? Because the derivative inside the parentheses is 1. So it makes no sense. Makes no difference. But what if this is 2x or x squared? Then this thing will change. And it will make a difference. So don't forget that here we have a problem about chain rule. And an interesting question I want to ask my dear audience, that is, why? Why the inverse function of sine of x, its derivative is equals this one? Why? It's just a problem. You can think of it. Okay. Question 16. Question 16 is about infinite series, and the choice is just to give you a lot of statement, and it asks you which one is true. For A and C, let's first look at choice A. It says, okay, the series converges because the general term's limit is 0. This is not true. Why? Because for infinite series, its general term's limit is 0 is the necessary condition for converge, not sufficient condition. Which means if we only have this, we cannot decide either this one is converged or diverged. Okay. So A is not right. But I want to say something more about this. If we know, or if we find for infinite series that its general term's limit is not 0, we can make a conclusion that the infinite series diverges. This is true. Actually, this is a diverge test. Okay, we then can take a look at choice C. Choice C use the method ratio test, so we can just apply the ratio test. And as you can see, if you apply the so-called ratio test, this thing, when n is when we substitute n as n plus 1, the whole thing will look like this one, and times the reciprocal of the nth term. Here, don't be afraid of or don't get frightened by this complicated thing. Actually, all things here are polynomial, and for polynomial, what we care when doing limits is the coefficient of the highest order's term. Okay, first you need to find what is the highest order. For the numerator, here it is n to the power of 3, and here, as you can say, it shall be n to the power of 2, and if we do a multiplication, it will be n to the power of 5. And the coefficient, because this one, it is 1, and here it is 1, so the coefficient shall be 1. Pretty similar idea applies to the denominators. And again, the highest term, the order of it is 5, and the coefficient is 1. So the ultimate outcome shall be 1. But for ratio test, if the outcome is 1, it is inconclusive. That is, we don't know either this one is diverge or or converges. We don't know. So A and C both are wrong. Okay, then for B and D, both of them are using the method called limit comparison. And when you are using this method, honestly speaking, what is crucial is the thing that you are going to compare with the original series. The right answer is what? The right answer is D. So we choose D. And as you can see, okay, if we choose 1 over n and we do the limit comparison test, it will give us 1. And by the limit comparison test, okay, because n over 1, this series diverge, it is the so-called harmonic series, which I have already mentioned. So does this one. But why? Why we choose 1 over n? That is, the thing is that we need to think about, okay, for large n, what this behaves like, or in the end, what will this grow like? It will grow like 1 over n. It's kind of like the thing, I don't know if you study pre-calculus, it's kind of like the thing we call end behavior in pre-calculus. Okay, and how do we know about it? We can just divide n square divided by n square on both numerator and denominator, and for the numerator 1 remains, and everything else becomes unimportant when n is pretty large. And for the denominator, n remains and everything else just again become unimportant as n become larger and larger. So it behaves like 1 over n when n is pretty large. So we shall choose this one. Okay. Sorry. For question 17 says, okay, or it asks you to choose a function satisfy first the differential equation, second the initial condition. I think this one is not so hard. Why? Because, okay, we see this kind of function, which is the accumulation function, and according to the fundamental theorem of calculus, if we take its derivative, it shall be, okay, for this one, it shall be the function inside, and okay, of course, here you shall write x, which is actually this thing. So we can check that dy dx for D is this one. Of course, for C, it is also this one. So how can we choose from C and D? That is, okay, we have initial condition that it shall satisfy. For D, when x equals 0, when x is 0, actually, for this integral, it is 0, and 0 plus 2 is 2. So it is true. So we just choose D. For C, actually, if you put x, if you put 0 here, then you get an integral. It's kind of hard to evaluate, or not hard, but you know, it is a multiple choice question. So once you get the right answer, you can just ignore all of this. Okay. Question 18. Question 18 says, okay, we have a geometric series, and we know its second term, we know its third term, and what is the sum of this series? Okay, for geometric series, two things are important. One, it is a common ratio. Second, it's the first term of this series. To find its common ratio, we just do this calculation. We divided A3 by A2, and we get the common ratio, which is negative 1 over 3. And to find its first term, because we already have the value of its second term, and we just divide it by the common ratio we just get, and we can get the first term. And for the sum of geometric series, it is just the first term over 1 minus the common ratio, and you just plug all the values you get, and boom, you just get the answer. Okay, question 19. Question 19 is that okay, we have a function. We don't know its expression, but we know that it is a solution to the differential equation, this one, and we know initial condition. And it asks you to use the Euler's method, and with a step size 0.5, starting at x equal 1 to approximate f over 2. Here is the thing. For Euler's method, we need to remember the formula. But again, how can we remember the formula? Or we can think of another question, that why we cannot remember this. That is, I think, you don't get the idea of Euler's method. And let me explain it to you. The Euler's method is this. Okay, here I got a picture from one textbook. Suppose the blue or green line, or the curved one, is actually the graph of f of x. We don't know its expression, so if we want to evaluate it, some function value of it, we don't know how to do it. And Euler's method is that, okay, we don't know the expression of the function, but we know there is a specific point, just like here. We know that when x equals 1, y equals 2. Actually, we know that this point is 1, 2. And we know the slope of the tangent line. That is just the derivative at this point. Why we know this? Because we know its differential equation. And this differential equation, just you can get its value. You can get the derivative's value just by knowing the y value and x value. And then we want to make a approximation. Okay, for example, when x gets delta x larger, what is the y value? The y value shall be, the real y value shall be this curve. If we keep drawing it, shall be maybe at this place. But the Euler's method idea is that we use the tangent line. Okay, there is a corresponding point. If we make x larger by delta x, we have this point. We use this line to approximate the real. We use this point to approximate the real point on the graph. That is the fundamental idea. And the problem is, okay, how do we know the length of here? Actually, it is, how do we know delta y? It is pretty simple. Why? Because delta y over delta x here is what, guys? Delta y over delta x shall be the value of tangent of this angle. And the tangent of this angle, it is also the slope of the tangent line, which is dy dx, the derivative at that point. So actually we have this formula. And because we want the delta y, so all you need to do is just to put delta y on this side, so we get this. Okay. Before we solving this problem, I want to say more about Euler's method. Actually, according to this diagram, you can already see that if the shape of the function is concave up, then our estimation is here, but the real point is above it, which means we underestimate it. And again, or if the line is concave down, you can think of it, or you can draw it on your own. If it is concave down, then the real value shall be here, but our estimation is here. So our point, our estimation, our approximation is higher than the real value, which means we overestimate. Okay, so back to this problem. Euler's method, you can just write formulas, but I prefer use a table, which made things a little bit well organized. So we start from 1, 2, and just by using the value of x, y, and the differential equation, we can get the slope of the tangent line. Okay, so here 3 times y here is 2, and minus 4x, x is 1, so you get the slope of the tangent line. And the delta x actually here, it is the steep size. Okay, it is 0.5, and what we want delta y, and how we get it? Just the derivative times delta x, just like here. So we get dy dx equals 2, and so it is 2, and delta x is 0.5, so it is 1. So 2 times 0.5 is 1. So this is delta y. So we get a new point. That is, okay, x plus delta x. X initially it is 1, plus delta x. So 1 plus 0.5, 1.5. And the y plus delta y. 2 plus delta y, you get it right here, which is 1. So 2 plus 1, which is 3. You get a new starting point. So you write this point right here, and no, I feel sorry. And just do the same thing again, and you will get that the new x value shall be 2, and the new y value shall be 4.5. So from Euler's method, we just get f of 2 is approximately 4.5, and that's it. Okay. For question 20. Question 20 is, I think, it's just a little bit challenging. Okay, let's read about it. First, we have a function, but this function is a accumulation function. And it asks us at what value of x in the closed interval from -3 to 5 does this function have an absolute minimum? Okay. We can think of it in this way, or let me guide you in this way. This one, it is an integral, and x, if we choose different number, just a different integral. Okay. What about when x is, say, 3? Okay. So what's the value of this? From this diagram, we can say this integral actually represents the area of the blue part. Is this right? It's not right. Why? Because the whole part is below the x-axis, so it is not the area, but the negative value of the area. So we get it. It's meaning. It's geometric meaning. Okay, this is not hard, but okay, x can be any value in the closed interval. So this time we choose a different value. Say we choose 1. Okay, from 2 to 3, it seems naturally, but from 2 to 1, it's not naturally. How to solve this? Okay, there is a property for definite integral that we can exchange the upper and the lower bound of the integral. But if we do this, we need to put a minus sign before the new integral, and the two things are equal. And now let's think of this. Let's ignore the negative part first. Think of this 1 to 2 integral. The idea of this is what? It's just the negative value of the area of the green part, this triangle. And of course, we have an additional negative value. So the whole function actually can be separated into two branches. That is, when x is no bigger than 2 and when x is greater than 2. When x is smaller than 2, you can just rewrite it as negative, okay, from x to 2. If it is greater than 2, it's just okay, from 2 to x. And I think it is not pretty. I think it's not hard to identify that for this branch. Let's first figure out for this branch that when x equals 4, it reaches its minimum. Why? Because, as you can see, from 2 to 4, it represents the negative value of this area, okay? But if the value gets bigger, you're starting to add some positive value, which will make your value be bigger. But in the other hand, if the value is smaller than 4, say 3, you just get the negative value of this part, which is bigger than the negative value of the whole part. So when x equals 4, for this branch, it reaches the minimum. And what about this branch? For this branch, when x equals negative 3, it reaches its minimum. Why? Because think about it. When x, let's say, when x is in the interval from 1 to 2, you get an area first, and it's negative, but there is a negative sign, so you get some positive number. And okay, if the value is in 0 to 1, you are starting to make it small, but when x is 0, actually, those two parts are cancelled out, so you just get 0. But before that, it's a positive value, and then you just start to adding the negative value of the areas, and when it gets the smallest possible value, that is when x equals negative 3. So we just can identify the minimum point of it. Okay, and then it's just try to calculate the value that when x equals negative 3 and when x equals 4. And how to calculate it? You can just find the area of those corresponding places or region. For example, if we are going to find, okay, what will be the value when x equals negative 3, first we rewrite it as negative, okay, from negative 3 to 2, okay, the integral, and the negative, you remind it. And as we have discussed, those two parts will cancel out. So what we need is actually the area of this part. You can separate this part as okay, you can draw a vertical line here, and you can say this is a rectangle. Actually, this is a square because the side length is 2, okay, no matter which side. So 2 times 2, you get the area of this part. And for this part, okay, from negative 1 to 0, it's a trapezoidal, and we can find its area by its formula, right? The this side is 1, this side is 2, 1 plus 2, and times, okay, this is 1, and times, don't forget 2 times, okay, 1 over 2, and the whole thing, and don't forget what? Don't forget we have a negative sign here, so the whole thing we calculated out, which is negative 5.5. And when x equals 4, okay, you get this, and the geometric meaning is the negative value of this area. I mean, from 2 to 4, this area. You can also separate this region by first calculate this part and this part, and pretty similar. So, you know, trapezoidal and triangle. So you just plug those numbers and get its value, and don't forget it is a negative value of it. And the final result is negative 2.5. And make a comparison. This is negative 5.5. This is negative 2.5. Which one is smaller? Of course, this one. So when x equals negative 3, we get the absolute minimum. And that is question 20. Question 21. Question 21 is an integral of rational functions. And for this kind of question, the first thing we need to figure out is the degree of the numerator and the degree of denominator. For this one, the degree of the denominator, actually this is a constant number, so the degree shall be 0. And for the denominator, it is 2. So the degree of the denominator is bigger than the degree of the numerator. So we don't need to do something, some book called long division. There are problems we're going to investigate later that will involve this process. I will show you the process I will show you this process then. Okay, so for this one, we don't need to do that, but we need to do what? We need to do so-called partial fraction decomposition. That is, we separate this as a sum of two things. One is this, one is this. Okay, and here is the problem. That is, okay, how to find the value of a and b. Honestly speaking, there are two ways. The fundamental idea here is that, okay, if we write the two things together, okay, it will look like look like this, and because the two things are identical, which means this shall equal to this. So the first way to find a and b is that, okay, we just rearrange the numerator, so we get this, which equals 4, and as you can see, there is no x on the right hand side, so a plus b shall equal 0, and 3a minus b shall equal 4, and solve this system of equations, you can get a and b. The second way is that we can let x to be some specific value, especially values that are zeros of the denominator. Why? Because let's say, suppose we let x equal negative 3, then this part is 0. So this part remains, but this part we can just ignore it. Actually, a is eliminated. And when x equals negative 3 minus 1 is negative 4, and negative 4 plus times b shall equal 4, so b equals negative 1, and of course we can do this that to let x equals 1, so this part disappear. We only have this part, and when x is 1, this is a times 4, which shall equal 4, and we find that a equals 1, so we get, okay, here a is 1, b is -1, and we can just solve this integral to this, and you can further write in this as this. Just use the operations of logarithm, and then you just substitute x as 3 and as 2. You just do a subtraction, and you get the answer. Okay, that's question 21. Question 22. Question 22 said, okay, we have a function f of x, and the function is a particular solution to the differential equation, this one, and we also have an initial condition of it, and which of the following is an expression of f of x. This one, this is a, guys, this is a multi-choice question. What I mean is that, of course, as I write it here, you can use separation of variable to find the expression. But for multiple choice question, actually you can exclude some choices to find the real answer. How to do it? First, you can apply the initial condition that when x equals 0, y shall equal 6. So a and c is excluded. Why? Because when x equals 0, if it is a, it shall equal 1, but it's 6, so c is not appropriate. A is not appropriate. For c, it shall be 1 plus 6, which is 7, but it shall be 6, so c can be excluded. So A and D, B and D remains in the. Then how we can tackle this? We can take the derivative of them. For example, for B, we take its derivative, and the answer is this one. And okay, we just take a look at the differential equation. From the differential equation, we say, okay, 3 times x squared. Here we have 3 times x squared. But we have a y, which means the remaining part, the remaining factor shall be the function itself. In B, it shall be this one, but there is no plus 5, so B is not the right choice, so it is D. You can check it. I mean, you can take its derivative, and the final answer is this one, and you find, okay, 3 times x squared, so you get this one, and the remaining factor, okay, it is itself. That's it. And of course, you can use the method separation of variable to find it. I just write the steps thoroughly. Maybe you can hit the post and take a look. But for multiple choice question, I suggest that you can use this way. Oh, what happened? I suggest that you might use this way. Okay. For question 3, it says, okay, we have a line y equals 2, and which of the following function has a horizontal asymptote, which is this line, and I just label all the horizontal asymptotes of them. So for this one, it is y equals 2. For this one, 2. This one, -2. This one, 1. So we are looking for this. So the choice shall be 2. But here I want to say something more, especially for the choice D. For horizontal asymptotes, actually, for a function, it can have at most 2 of it. Why? Because you can just check the end behavior when x approaches positive infinity and approaches negative infinity. Okay, for this one, when x approaches positive infinity, this is 1. So y equals 1, it is a horizontal asymptote of it. But if we're looking for the horizontal asymptotes on another side, that is when x approaches negative infinity, actually this limit do not exist. Okay, maybe I shall write does. Just forgive me, okay? Does not exist. So what I mean is that for this one, yeah, it has it has a horizontal asymptote, but on another side, it does not have such a one. For ABC, actually, you can check that both sides they have horizontal asymptotes, and the interesting thing is that on both sides the horizontal asymptotes you calculated is the same. So there are so this is their these are the horizontal asymptotes of them. But there are chances that maybe for some functions it will have 2 horizontal asymptotes. Just pay attention to this. Okay. For question 25. Question 25 says that what is the parameter of the region enclosed by the graph? Okay. Y equals 3 and a parabola. Okay. X squared minus 2x. Okay. We can first find the intersection of the 2 curve. I mean, this is a straight line, but we also can call it a curve. And then we just solve this system of equations, and we find, okay, the intersections x coordinate shall be 3 or -1, and we can just draw these 2 graphs. And as you can see, the intersections, the x coordinate here shall be 3, and the x coordinate here shall be -1. So let's think about the perimeter of this region. Actually, you need to find 2 lengths. One is the length of this straight line, which is pretty simple. That is, okay, 3 minus -1, so 4. But what about this curve, this parabola? What we need to apply here is the formula for the length of the curve, which is this one. And again, how can we remember this formula? And I said it several times. You shall. It is not vocabulary. You cannot remember it, or you shouldn't remember this as just like graph. Okay, graph. You shouldn't do this. You should remember the idea behind it. Okay, so the idea is that I just choose a figure here, and you can see. Suppose we're going to find the length of this curve, okay, and we just have this point, and we call this length from this point to this. We call this delta x, and we call the difference of the height is delta y, and then delta s. We have no special formula for calculating delta x because it is a curve. But guys, think about this. As delta x gets smaller and smaller, this curve, we can use a straight line to approximate it. And when we're doing this, actually, we have a right triangle. And for a right triangle, we have a pretty famous theorem, Pythagorean theorem. And so delta x is approximately equals this one, delta x squared plus delta y squared, and take the square root of it, Pythagorean theorem. And we just divided for both sides we divided by delta x, and we get this, and on this side delta x square divided by delta x. If you let it into the square root, it will be delta x squared, so it is 1. And then for this one, it is this one. And then, if we let delta x approaches 0, what we get is actually this formula. And for this formula, okay, we keep going. We just take the integral of it, and we get the length of it. And for this side, we just do the same operation, so we get this formula. So the idea behind it is just a pretty famous theorem, Pythagorean theorem. So starting from this point to this point to this point, and finally this point. This formula, how we get it. Okay, then let's apply this formula to this curve, and we know that the function represent this curve is this one. So we take its derivative, which is 2x minus 2. And according to this theorem, it shall be 2x minus 2 squared plus 1. And the lower limit and the upper limit of this integral shall be -1 to 3. So we get the length of this curve. But don't forget, we need to find the perimeter. So we just add 4 ahead, which we have find. It is the length of this straight line segment. Okay. For question 25, it said, okay, we have a function, a continuous function, f, and we know that big F is an antiderivative of it. And then, how to evaluate this definite integral? Okay, the technique we are going to apply is called integration by substitution. And okay, we just let the whole thing in the bracket to be u, and we can take the derivative of u with respect to x, and it is 3, so we can find du equals 3 times dx. Also, you can think of it dx equals 1 over 3 times du. And another thing is that when x is -1, u shall be, okay, we just substitute x as -1, and it is 3 times -1, which is -3, and plus 4, so you get 1. And the same idea when x equals 2, so u equals 10. So by doing so, we can rewrite this integral to this. Okay, guys. And finally, we get to here just by the fundamental theorem of calculus. So that's it. For questions 26, okay, we are going to evaluate a limit, and the numerator in this expression is the accumulator function. And for accumulator function, we just know actually 2 things. First, we know that it can be used to represent area, dynamic area. Second, it is the fundamental theorem of calculus. That is, if we take the derivative of it, it will equal tangent x. So, and here we are evaluating a limit. It seems that there is little possibility that we're going to apply it to evaluate some area. So maybe at this point you can think of it, okay, maybe I shall take derivative of it. Then let's see this limit. Okay, as x approaches pi over 4, the numerator approaches 0 because the upper limit and the lower limit is the same. And for the denominator, it is also approaching 0. So 0 over 0. And indeterminate form. No matter from here and no matter from here, I think you can think of that we shall use L'Hopital's rule, because okay, in the indeterminate form and take a derivative, what else? So we just apply L'Hopital's rule here, and we get this one, and we just substitute x as pi over 4, both on the numerator and the denominator, and okay, tangent of pi over 4 is 1, and here you get pi over 2, and finally 2 over pi. That's it. For 27, okay, again, integration of rational functions. And just as I said previously, we shall first figure out the degree of the numerator and the denominator. I'm sorry. And here, the degree of the numerator is 2. And for the denominator, it is 1, which means the degree of the numerator is bigger than the degree of denominator. So, we shall first apply the so-called long division or division algorithm. Different books may have different names. And what is long division? I just write it here. Okay. And from this, we can get what? We can get that this can be written as, okay, a separate x minus 2 from here. And plus, actually here it is plus negative 5 over x plus 2, because it's negative, so we can write minus here. So that's why we are going to apply long division, because we can write this to this. And if you going through the course of so-called AP Pre-Calculus, you might also know a method called synthetic division. That is this. If you use this method, you can check this, and we can also get the answer. As you can see, the coefficient of x is 1, and the constant term shall be 2, and the thing remaining is negative 5, just the same thing. Okay, to evaluate this is straightforward. You just apply apply some general principle, and you can get this. Two things to be mentioned. One, there you shall write absolute value. Okay. Second, don't forget plus C. This question is a multi-choice question, so maybe you can think of plus C when you take a look at those choices. But if it is a free response question, please don't forget write this, okay? Because it's a indefinite integral or antiderivative, so you cannot ignore this, okay? For this question, a polynomial actually times exponential function. The general principle is to use the technique which we call integration by parts to solve it. And the process is like this one. Okay? We just think, okay, e to the power of negative x is the derivative of this function. So the whole thing equals this times this one, and minus, okay, this time we take the derivative of x, which is 1, and times the remaining things. And minus minus, so we get plus, and for e to the power of negative x, we can easily find its antiderivative. And for this part, okay, we just get to here, and then just to pay attention to the infinite sign here. So it is a improper integral. So for limit here, actually you are going to evaluate that when x approaches infinity, what is the value of this thing? For this thing, actually, it's pretty trivial to find that this is 0. Why? There are two ways to solve it. One is actually you can use the L'Hopital's rule, because it's infinity over infinity, an indefinite form. Second, and I suggest the second way is, okay, the numerator, which is a linear function, the denominator, which is a exponential function. Exponential function grows much faster than linear function. So when x gets pretty large, the denominator is way much bigger than the numerator, so it approaches 0. And for this, you just substitute x as 1, so you get this. And for here, same idea. You just see the limit when x approaches infinity, and this is 0, and this is just a result of substitution. And okay, just write. We can just write this. So the final answer shall be 2 over e. Next question. Okay, next question said we have a curve. We have a polar curve, r equals theta squared, and we want to find the slope of the line tangent to the curve at the point where theta equals pi. Okay, we're going to find the slope of the tangent line. So I'm sorry. So you must find divide x. Okay. The problem here is it is not a function in xy form. It is in polar form. So how can we do this? We can do it by use a so-called polar rectangular conversion formula. That is x equals r times cosine theta, y equals r times sine theta. And for this specific polar curve, x equals r times pretty sorry. R times cosine theta. And here r is theta squared, so it is this one, theta squared times cosine theta. And pretty similar, we can get y equals theta squared times sine theta. And then it's pretty much like the way we treat a parametric curve, so we can find this formula. Okay, if you are going to find divide x, all you need to do is first find divide d theta and divided by dx d theta. So divide d theta is this one. It's just some basic derivative, and the dx d theta, this one. Okay, and so you can find dy dx. Okay, it is an expression about theta. And now just substitute theta as pi. So here sine pi 0, so you can ignore this part. Sine pi 0, you can ignore this part. Cosine pi -1, and theta squared, which is pi squared, so numerator negative pi squared. Here -1 and 2 times pi. So you get this, and simplify it, we get pi over 2. That's it. Question 30. Question 30, I think, is the simplest one, because all you need to know is that the Maclaurin theory of cosine of x is this one, and okay, it matches, right? It matches. I mean, the two things matches. 1, 1, okay. 2 factorial, 2 factorial, okay, something square, and so it is. The whole thing is just cosine of pi over 3, and the value of it shall be 1 over 2. And Okay, from question 1 to question 30, usually these are multiple choice question which graphing calculator is not allowed. And next part, we're going to investigate multiple choice question that graphing calculator is allowed. So see you in next part.